Welcome. Let's go over how to use the latest version of my expansion calculator, version 29E. If you look at the bottom left, you see tabs for 4 different sheets. When you click on the tab, it'll take you to the sheet. Sheet 1 is kind of the beginning, not really. Sheet 4 is the beginning. It's the beginning and the end. Right here is where you put in the data for the exhaust port. And if you don't want to take the time to trace that port and measure those, just by putting in the data about the port and how many exhaust ports there are, like if you get 2 auxiliary ports, that's a 3 port. And then you can just click right here, calculate port widths, and it will do it for you. It's just a gross estimation, but in a lot of cases it's close enough. If you after you enter the data right here, if you click the calculate button, and this right here is less than 0.9 for a multi-port exhaust or less than 0.85 for a single port exhaust, then you're going to have to raise the exhaust port to get the best power at top RPM. This is very good right here. That means that the end of the exhaust pressure in the combustion chamber reduces to 0 to allow the transfer to happen of the intake charge into the combustion chamber at 97% of the transfer port opening. So a little bit of overlap is okay. Like I said, 90% or 85%, depending upon the style of the exhaust port. So, you enter in all this data right here in the light blue cells. You click the calculate button right here. Then you go back to sheet 1 and you finish entering in all the data. Leave the temperature as it is. Probably best to analyze your pipe that you have on it right now, because you know at what RPM it comes on the pipe and what RPM it gets off the pipe. So you can enter the beginning of the pipe power band here, the end of the pipe power band here. And if you don't know, maybe you've got a dirt bike. Let me see if I can find the calculator. Yeah. This right here is a calculator to help you find the RPM for each shift. So if you know the upper RPM, you put it right here, and then if this agrees with reality as far as the so you got to know one or two things. You got to know the RPM. You got to know the speed. So if you keep changing the RPM right here until the max speed shows up here for whatever corresponding gear, then you know it's right. If it's wrong, you got to keep changing it until it's right. And by that you can know what the top RPM is. So yeah, just enter all the data, the dimensions of the pipe, the thickness of the pipe metal. If you don't know what that is, just leave it as is, 1.5 and 1. Leave this area unless it's fixed ignition. It's not a normal CDI. Don't touch either of these. Enter in the data for your existing pipe right here, and leave sheet 2 set on automatic for the diffuser and automatic for the baffle, and then go to sheet 3 and click on the autograph button, and it will give you this pipe power. It'll show you the RPM when it comes on the pipe, the RPM when it gets off the pipe. If this isn't in agreement with what your bike is doing, that means that your temperature is not correct right here. So, for instance, if you know that that pipe power band ends at, let's say, 11,000, you need a higher temperature right here. Let's see what this does. Recalculate by clicking on the button again, and we're getting close, so probably a little bit over 700, maybe 725. So just keep doing that until it's in agreement with what you're experiencing. Right now I'm going to bring it back to 600, which is very typical at 10,000 RPM. And yeah, just following the steps here. Into gas pipe diameters, vary lengths. This is for designing. So let's just ignore that right now. We want to analyze your pipe. This is the stinger length right here, inner diameter of the stinger. These are all inner diameters. The waves work with the inner diameters, not the outer diameters. So this is a simulator of the return waves. This is time-wise, this is transfer opening, bottom dead center, transfer close, exhaust close, diffuser wave, and baffle wave. And this little green line right here is the secondary return waves, which do change the height of these waves. So yeah, it's just as simple as entering all the data and clicking on the ontograph. So if you want to store any results, you can click on these buttons right here, which is store in whatever rows. Your final, the data for the pipe will be right here. So you use your current setup to find out what your temperature is. Okay, let's say in reality it's 650. Okay, so now you want to design a new pipe and see how it compares with your old pipe. Maybe you just want to modify the old pipe a little bit. So now, if you have a flared header, you would want to enter the distance from the piston face to the beginning of the flared header right here. I say if you have a flared header, but if you want to design a flared header. If you're turning a motocross bike into a trail bike, you don't want a flared header. The flared header is just for top RPM horsepower. It works against having good mid-range power, which you definitely want on a trail bike. But let's say we're going to keep it as a motocross bike. You want the flared header for a motocross bike. So it says right here, calculate for flared header. It's actually calculating everything for a pipe that has a flared header. Or click here for a straight header, which is calculating everything for a pipe that just has a header that's straight. So I'm going to click right here. And that gives you the distances. And then on sheet 2, you can leave it on automatic if your baffle cone is single angled like this. If it's not, you would either have to use this right here to find out what the angles are, measuring the diameters and the distances, and then recreate it right here Or if you want to experiment with either these two designs, you would want to click here, delete, enter, X, enter for manual, because now it's not going to go by what it calculated for a single cone. It's going to go by whatever you enter right here, which is pretty straightforward. It has the belly diameter right here, and it's asking for the first cone angle if you're just going to like if you're going to do the increasing angle baffle. The first cone angle is right here, 6.9. And the distance is right here, 30 millimeters. So since everything works in sections of 10 millimeters, you just go by these first three numbers. So you'd enter these three right here. 17, enter, 17, enter, 18. Okay. The diameter there is 67. I'm sorry, 87.7. So you would put that right here, 87.7. And the angle right here, well, that diameter's listed right here also, is 15. And the length is 60, so you do want to record the first 6 numbers here. Starting where we left off, 40, 42, 45, 48, 52, 57. Okay, and last we've got 22.6. And the beginning diameter is 55.6. And we want the first 4 numbers because it's 40 millimeters. So it'd be 93, 108, 128, and 158. As for the baffle wave, those numbers are used by the return wave simulator on sheet 3. Here is the section for the diffuser cone. So if that X is an automatic, then you don't have to touch anything in this section other than this right here. You have to select whether or not you want a 3 cone for reap valve, 3 cone for piston port, or single cone diffuser, which a lot of high RPM power bikes use a single cone. So if you're analyzing a pipe, you'd probably want to put it on manual, just to make sure that the wave that's going to be graphed is going to be the same as what you got on your bike. So just using this and measuring the pipe, you'll be able to know what the angles are, and it's the same setup as for the baffle. For whatever the length of each section is, you'll put those numbers here, and then it wraps around right here and keeps going, because it allows for a very long diffuser. Okay, but I'm going to go ahead and put this back on automatic. And like I said, this stores the numbers of the pipe. So that's pretty much it. You know, just you analyze your pipe, you adjust the temperature so that the power band matches the RPM band that you experience in real life, even though you may not be able to feel it except for up here and up here. but still, you know, you know what that center is, okay? And then you can use these two numbers to calculate a new pipe, and then you double check its band right here, and if it's too high, uh, you'd want to lengthen the header. If it's too low, you'd want to shorten the header. But usually it's pretty right on. So uh, going back to sheet 4, this helps you to make your own cones. This is the cone pattern right here. So if you enter in the large diameter, the small diameter, which would be this diameter and this diameter, and the angle from center, it's not the total angle, it's the angle from the center line, then it will tell you the lengths of A, B, and C. I'm pretty sure that's right. Chord. Yeah. And so with a long ruler and some poster paper, you can draw that line, that distance right here. You can mark it for the right distance of A, and then as you keep that point right here, as you move the ruler, you'll be able to put another mark here, another mark here, and you wind up making a dashed line for these two. And it'll probably extend farther than this because you don't know exactly when that chord ends until you measure it. You have to have the curve to measure it. So just go far out here, and then you connect the dots with your pencil, and then you keep moving the ruler as the chord until it agrees with this distance right here. And you say, this is it right here. So you mark it, and then you draw that line with the ruler back here. So then you've got that curved line, you've got that curved line, you've got these two straight lines, and you just with your scissors you cut this out. Then you place that on top of the sheet metal, and with a Mark-Slot you draw around it. Okay, and then with the tin snips you cut that out. And then either manually or with the machine you can bend it to make the cone. I just do it manually. I find something curved to press it against, or to use a rubber mallet to bang it against. And that pretty much covers it. It looks daunting, but it's really not that hard. And I don't want you to be shy if you say, Michael, I need some help. I'm like, that's fine. That's what I'm here for. You know, I'll get on the phone with you, or, you know, you email me the spreadsheet, so we'll both be looking at it at the same time. And we'll just go over it step by step. I want to make sure you get a good pipe. Okay, thanks for watching.